Welcome this morning to this morning's session on exam preparation AZ-400, where we're going to be talking all about implementing Azure DevOps. By a show of hands, how many people are already certified from previous certifications in Microsoft? Doesn't matter if you're MCSD or MCSE. Oh, even better. Okay, very good. Well, my name is Dwight Goins, and I am a Microsoft certified trainer. I'm also a Microsoft regional director. I'm an ex-Microsoft MVP. For the past 10 years, I was a Microsoft MVP in quite a few different topics. And recently, I've been graduated to, I guess you can call a Microsoft regional director. I've been in the field for over 20 years as both a developer and an architect, doing all kinds of things. I'm based out of Coral Springs, Florida, which is about 3 hours south of here drive. So you guys are in my backyard, so welcome. Oh, by the way, if you want to keep in contact with me, that's a QR code to my LinkedIn profile. Feel free to take a snapshot of that and link up if you'd like. So today's agenda is to talk about the certification overview, talk about the new role-based certifications. So for those that are coming from a previous form of certification, you may be interested to know things have changed some, so we'll talk about that. And then we'll get into the exam objectives. We'll start talking about all the different key points you need to understand for going out and passing the AZ-400 exam. And then after that, along the way, I'll be providing you tips and tricks on everything you need to do to be able to pass that exam, and we'll talk about how to prepare for it, okay? So the key takeaways that I'd like for you to really focus on, the three things I want you to really get out of this is, number one, what is the objectives? What are the key things that you need to prepare for the AZ-400? Number two, the format of the questions. They may be a little bit different for people who have never taken Microsoft exams before. So I want to make sure that you're at least aware of the format of the questions. And number three, where are references and links for preparation for this exam? So you'll be provided with that as we move along throughout this process. Okay, so the first part of this is certification overview. But before we actually go all into the certification, let's just talk about the history of what's happened in the Microsoft certification space. So for those people that have been certified before, which looks like the majority of you have been, we all know that sometimes it took 6, sometimes 7 exams to get that top tier certification. And that top tier certification, be it a MCSE or MCSD or MCDBA, right, it basically spawned a very specific tier of whatever it is that we were focused on. Well, as time has changed and the industry has changed, if you think about, let's take for a DBA for a second. A database administrator is no longer focused on just a SQL database. Now a database administrator has to have their hands on relational databases and non-relational databases. They got to worry about Cosmos DB, they got to worry about Graph, they got to worry about column tables, they got to worry about DocDB. So now, as a DBA, it's no longer simply a database, a relational database. It now spawns all these different touch points, right? The same thing with a developer. A developer is no longer just a developer who writes code for desktop apps or web-based applications. A developer now has the task of building code in all kinds of places, from PowerShell scripts to Bash shell to building pipeline components, which is what this is all about. So developers spawn many different tasks as well. So what Microsoft realized was that the roles and responsibilities for these different certifications were changing. So Microsoft needed a way to refocus certification based off of roles and responsibilities. And that's pretty much what this slide is just kind of alluding to. If you're interested in developing apps and working with infrastructure in Azure, then you want to look at that particular role and responsibility. So when you start with that role and responsibility, if you're interested in becoming what we refer to as Azure DevOps certified, right, there are certain paths that you could take to get there. So the first path is if you're more on the infrastructure side, more on the admin side, you can go and take Azure 103. That's the exam number that you could take. You could pass that, and if you pass that, then you'll become an Azure Administrator Associate. And then once you do that, you have the first requirement, let's say satisfy, for becoming an Azure DevOps expert. The next exam would be this exam, AZ-400, and once you've passed that, then you become Azure DevOps Certified. So that winds up being just 2 exams. As before, it would be 6 or 7 exams to get that top tier certification, but now it's just 2 exams. Now, if you're a developer you don't have to go that route. You could take the AZ-203 and then pass that, become a developer associate, and again, take this particular exam we're going to be talking about, pass that, and you become Azure DevOps certified. Is that pretty clear? Yes? I see some heads shaking. Okay. If not, just see me afterwards, and we could talk a little bit more about it. I was at the Microsoft certification booth all day yesterday and the day before. So, I don't think I'll be there today, but again, if you have questions on the certification process, just see me afterwards. So because of these role changes, Microsoft wants to make it clear that this particular exam is for what we refer to as a DevOps engineer. All right, this DevOps engineer, their normal tasks are most likely going to be involved with overseeing or making sure that the build components of a team has been properly created, that the environment is properly situated, that you have source control available. So when you have a team of developers, they put their code in source control and they can build properly. And you probably need to go and run through a variety of other tasks and a variety of other software frameworks and components. And that DevOps engineer is pretty much tasked with making sure all that stuff is set up properly and works properly. Okay, and if they have to write any scripts in order to launch some runners or integrate with other pieces, they're most likely tasked with doing things like that. So the learning path for Azure DevOps Engineer is pretty much straightforward. You have the ability of going as an administrator or going as a developer, right? So you don't have to pass both of them, just one of them. And once you pass one of those exams I mentioned earlier, then all you have to do is pass the AZ-400. Now, what's new with the exam certification process is this thing called performance-based testing. Performance-based testing is this idea where you're presented with a web page that has Azure VM. And you're in this environment inside the Azure VM, and they provide you with a set of 10 to 12 tasks. 10 to 12 tasks. It would be great if it was just one task, right? And those 10 to 12 tasks basically just say, get these tasks done within the allocated time. Doesn't matter how you do it. Doesn't matter if you write script to do it, use Visual Studio to do it, drag and drop your way to success to do it. Doesn't really matter. As long as you get the explicit task done by the allocated time, you pass. Right? So those performance-based tests are coming. They're not, well, I know some of the exams are live with them now, but not all of them. So if you go and take some exams, you might have either a portion of your exam that's a performance-based test question, or you might have the whole exam that's that way, all right? So look out for that example fairly soon. All right, with that being said, let's get into the exam objectives. We have a lot to cover in a little bit of time. So you ready? All right, let's do it. So AZ-400, we have about 7 buckets of things. So what that means, when you're taking this exam, you have to switch contexts 7 different times as you go through these questions. And no, it's not in any particular order. It would be great if you could just focus on the first concept and go, okay, whew, done with designing and implementing a DevOps strategy, right? It'd be great if that was the case. But the questions are all just sporadic. They're all around the place. So you literally have to switch contexts in different forms of fashions, all right? Those 7 contexts are, number 1, design a DevOps strategy, which is about 20 to 25%. Number 2, implement a DevOps development process, which is another 20 to 25%. So potentially right there, that's half your exam, okay? So we'll focus on those 2 pieces. And then implement application infrastructure. We'll talk about that. That's this idea of, well, we'll talk about it. That's like desired state configuration and stuff like that. And then we'll go into continuous integration, continuous delivery, continuous feedback, and dependency management. Not necessarily in that order on purpose. So the first topic is design a DevOps strategy. And this topic, this is all about recommending which type of features that exist in Azure DevOps based off a set of scenarios that they provide for you. So what does that mean? That means you kind of need to know a little bit about all the different features of Azure DevOps. You need to know about boards. You need to know about like the Azure boards, and you need to understand that the boards are used for managing your project and creating user stories and managing sprints. So you need to know all of that stuff, okay? You also need to know about the pipeline, what the pipeline is, such as continuous integration and continuous delivery or deployment. So the pipeline piece would be the components that pretty much chunk together the build process, the packaging process, the versioning process of your components, and of course, the release of your application. Right? So you need to know that's what the pipeline is for. You also need to know in the pipeline the differences between a build pipeline and a release pipeline. So I'll drill into that more. All right? So the whole concept here, when we talk about designing a DevOps strategy, is we just want to make sure you understand all these different facets of Azure DevOps. And so understanding the pipeline is the first thing. And then the next piece of that is artifacts. So there's a few questions on Azure artifacts. So Azure artifacts is kind of like the container, so you will, or the bin directory of where all of your output goes. Right? Think of it as a shared repository, in lack of a better word, where you can publish releases of your code. Now, starting with this week, I think there was a new announcement. Azure Artifacts before was typically an internal thing for your internal enterprise. But starting this week now, they've created it so that now Azure Artifacts is public now. So what that means is you can give external links for external partners or for just the public world to access whatever your releases are, whatever your code is. Anybody here ever use a JFrog Artifactory? Okay, for a few of you. For those that have used it, it's the exact same thing, right? Except it's now all in Azure, all right? So then we have artifacts, and then we also have the Azure Test Plan Management mechanism, which allows you to create load tests and stress tests and unit tests, so understand a little bit about that as well. And did I mention source control? Maybe not. We also have Azure Repos. So Azure Repos is all about source control, where you have developers that are typing in code and developing applications, right? They need a place to store their code. So that's also a part of the Azure capabilities and features for Azure DevOps. So you need to make sure that you understand that the Azure Repo part is all about being able to keep track of code that's been typed up, written, and saved, right? And you have auditing purposes and stuff like that, but we'll drill into it. So the DevOps strategy is really understanding what the features are, and then based off of the requirements that are given to you, figuring out which features that you would use for said question. So let's drill a little bit more into this. So when we talk about boards, specifically, some of the things that they're going to question you on are things such as the different type of charts, right? Make sure that you know these different type of charts. I think I have a slide on them here. Sorry. Make sure you know your different type of charts. Make sure you know your work items. Make sure you understand what sprints are. Basically, you kind of have to put on the role of being a Scrum Master for a second when they talk about the boards, right? You got to understand things like lead cycle time, burn down charts, and different things of that nature. I'll go into those in just a second. So again, this is all about knowing your tools. So when working within an Agile process, understand there's a difference between a user story and a product backlog item. So I'm just swapping between that. When we talk about Scrum templates and CMMI, just understand the difference between Scrum and Agile, and then understand the difference between CMMI. CMMI is all about just document retention, and it's more of an industry government standard. Also know your terms. Know the difference between a product backlog, a user story, work items. Also understand the difference between a lead cycle time, a burn down chart. These are all questions that they may particularly ask for you. So let's talk a little bit about that. Burn down chart. So a burn down chart basically allows you to figure out how well the team is doing over time, how many items are left pretty much over time. If you take a look at the velocity, if your team has set up estimated story points, so if your team has estimated the particular task, right? If you played Scrum poker before and you figured out how to score how long something's going to take, and you did it, instead of giving it as a number of weeks or a number of hours, you represented that as a number of points, then you could use velocity. And velocity allows you to see how many items are being implemented or how many items are left based off of the estimation, and allows you to kind of see what the velocity is of how well your team is implementing that particular item. Then we have WIP limit. That's the work in progress. So the WIP limit, again, if it's something that you've set up inside of Azure DevOps, the work in progress is this idea that, all right, I'm looking at my team's capacity, and my developers can only do 3 things a week, or 4 things a week, or 2 things a week, or something along that lines. So all the work in progress limit means is how you're putting a soft threshold around how many items can be assigned to one particular developer during a sprint, okay? Understand a little bit about Kanban board, how that's kind of like a sticky note board that you can drag and drop items to the doing and done and progress. They don't really ask too much about things that say how to configure your Kanban board, because that's not really what it's about here. It's just making sure, again, this is all about developing a DevOps strategy. So this is all about when to use a Kanban board versus something else. So some sample questions. Here's one, true or false? Work in progress limits places a hard constraint around the amount of work your team undertakes at each work stage. Is that true or false? False, great. Why? Why is it false? Keyword is the hard limit. It's not a hard limit. You can assign as many items to a developer as you want. It's a soft limit. You just basically type it in, and then it just tries to keep up with it, right? But it's not a hard, fast rule. It doesn't block your code. It doesn't block the usage. It doesn't mean you can't do it. So it's not a hard, steadfast rule. All right, next question. Which chart is most affected by the done date? So the done date is something that allows you to see when a particular task is completed. So if I go back to the charts here, one of these particular charts allows me to see the complete time it took for when the item was first created to when it's completely marked as done. And that item is the lead time, okay? So I maybe didn't explain that one early enough, but yeah. Next one, which chart best helps with sprint planning? So what you need to know about with sprint planning is how much can your team do? Did I hear it? Velocity, exactly. So velocity deals with sprint planning. So these are the type of course, now when they give you these questions, they're gonna give it to you in multiple choice, but just kind of directly knowing the answer eliminates all the guesswork, all right? Next question they'll ask you is something along the lines of, which chart allows you to predict when remaining tasks will be completed? Burn down chart, exactly. Because the burn down chart allows you to kind of gauge what's happening over time, how many items are left, so it allows you to predict when something might be completed. All right, so the next bullet point that we have under designing a DevOps strategy is design a quality strategy. And this is all about testing and verifying that the code is up to certain metrics, certain service level agreements, and things of that nature. So when we talk about this is where things start to get a little bit tricky, simply because Microsoft doesn't necessarily have a tool out of the box other than the test plans and test centers. It doesn't really have a tool out of the box that kind of sweeps the whole gamut of how do you test performance, how do you test code coverage, right? They're all like disjointed products, okay? So in this particular section, all you're really looking for is probably names of open source packages that can scan your code for code coverage. You're looking for open source packages potentially that can validate that you don't have any security vulnerabilities and things of that nature, okay? So if you think about that, some of the tools that Microsoft recommends, if you've gone through any of the labs and any of the examples on GitHub for Azure DevOps, they recommend things like Veracode, they recommend things like SonarQube, Selenium, right? These are all different packages that can do these different types of things. And of course, the obvious, the Visual Studio code coverage that you have as a part of Azure DevOps. Another thing to make mention of here is feature flags. So there were a few questions on feature flags that I remember. And feature flags is all about, as developers are implementing new features, instead of going through this concept of implementing a feature branch, because we will be talking about branching strategies, right? Instead of going through the complexity of feature branches, Microsoft kind of recommends that what you do is you use feature flags. Now, how many people here have heard of feature flags before? Oh, even better, the majority of you. For those that have not, feature flags is this concept where as you develop your code, you basically use conditional checks in your code that are read from some config feature flag setting that allows you to simply say, okay, I'm starting to work on a new feature. Let's say this new feature allows me to send XMS text messages to mobile devices in my web app, right? But it's not quite ready yet. So what I do is, instead of me having a branch that has all that code, I just put that code kind of in the main development branch, but I wrap it around a conditional statement that says, okay, if the flag is turned on, then do this code. Otherwise, just skip that area altogether. Right? And that makes continuous integration easier, and that allows you to quickly turn it on by a configuration item or maybe by a setting inside of another web page at runtime. Right? So that's the idea of feature flags. So Microsoft recommends that use feature flags whenever you have a bunch of features that you want to implement. And so whenever you see questions that deal with feature flags, that's kind of what they're talking about. So earlier I made mention of the fact that when we talk about designing a quality strategy, all Microsoft is looking for here is that they want you to understand that there are a lot of products out there that can support verifying code coverage, verifying performance, verifying security vulnerabilities, and these are the typical ones. These are the ones that you could find on the labs, on the hands-on lab, right on github.com and under microsoft.com/learn for this particular exam. You'll see stuff in there about Selenium, you'll see SonarQube, and so on and so forth. So here's some sample questions. You're a developer that works with Azure DevOps Pipeline. You have an environment where there are web servers that do not have Visual Studio installed on them. The problem statement or requirements. The web development team has included the Selenium test framework for testing the application. The goal? You need to create a pipeline that can deploy the web application successfully to a website upon successful test. What steps should you take in order to complete the task? Now, a couple of points I want to point out here. This is a typical format of an exam question. They present you with a scenario, they present you with a problem statement, they present you with the goal of what you're trying to do, and then they ask the question. Okay, for those that have taken exams before, you're probably already familiar with this. For those that are brand new to this, this is the type of question that you see. Okay, so what's important about this is, number one, they told us that Visual Studio is installed on some web servers. Okay, so if Visual Studio is installed on web servers, do you guys think this is a production box? I'm not talking about real life. I'm talking about the best practice. If Visual Studio is installed on a web server, are we talking about a production system? Probably not, and hopefully not. Hopefully you're not doing this, okay? So that's number one you probably should be thinking. Next thing they say here is, okay, so we have Selenium. So what is Selenium? Selenium is one of those tools that allows us to do some type of testing, unit testing, automated load testing, right? So knowing just a little bit about Selenium, you don't have to know the technical details of how it works. You just need to know what it does, right? Again, we're all about designing a DevOps strategy. You follow? All right, the next thing it tells us that, okay, we need to create a pipeline that can deploy a web application. All right, so we know we're creating a pipeline. Guesswork is out of there, all right? So what steps do we need to do? So these are the possible steps that you could choose. Create a build pipeline, create a release pipeline. Out of those two, which one of these pipelines? Why build? Right, we're testing it. It's in a test phase, it's not in a release phase. Now, of course, you could do this in a release phase, but that's not really what we're focused on here. And we're focused on a test environment, a QA environment, right? So we'll most likely choose a build pipeline. Then it says add a deploy Azure App Service task, add a Visual Studio test task, add a Visual Studio Platform installer task, and configure the platform version. So we didn't talk too much about this, so I'll just give you the answers. So the answers are add a deploy Azure App Service task, a Visual Studio Platform installer, and a Visual Studio test. And let me explain why. So what the App Service task allows you, so Selenium is a third-party product. That means you most likely have to install some type of agent or install some type of mechanism on it. So you need an installer that can do that. Another thing that you have to do is you have to tell the system that this is like a test system, okay? And that's kind of, so the installer is for installing the agent. Telling it that it's a test system is what the Visual Studio test task does. It basically says this is a testing mechanism. And then the Azure App Service task is the task that allows you to connect up to Selenium altogether. All right, next topic. Design a secure development process. So this is all about how do we make sure when we've coded our application, we've compiled it, we have our pipelines and stuff running, how do we make sure we're following security best practices when designing a DevOps strategy? So security is all about this concept that when you're developing applications, you tend to use frameworks, right, that are shared. And sometimes these frameworks have other shared components, right? And if you've ever worked with a team of developers before, I'm sure a lot of times you hear developers go, hey, let's use this new open source platform or this new open source library. Which, if you're an open company, you probably would be okay to doing that, especially if it increases the speed and velocity of your team to get various different tasks completed. The problem is a lot of open source tools use a lot of other open source tools that could potentially have vulnerabilities in them. So from a security best standards or best practice, you want to make sure you could scan all of that. You want to make sure that there's no security vulnerabilities. You want to make sure it follows the open web access project, right? You want to make sure, our open web application security project, you want to make sure that it follows security best practices. So when we talk about designing the DevOps strategy for security, we're pretty much talking about what tools are you going to be using to be able to scan open source vulnerabilities, follow the OWASP process, and different things of that nature. Another thing you're going to be thinking about when we talk about security is sometimes when we have applications, we store username and passwords, right, to in systems that we have to communicate with. Well, you don't want to store your username and password inside of a repository such as Git, because that's just text-based. You can simply search it and find the username and password. So another thing we talk about is where do you store your secrets? Well, obviously this is Azure, so we would love for you to store them in Azure Vault or any type of key vault. Okay, so that's another thing you'll hear about when we talk about designing the secure DevOps strategy. So let's drill into that a little bit more. So when we talk about designing a secure strategy, we want you to think about threat modeling. We want you to think about, and we want you to identify potential places where username and passwords might become compromised. We want you to think about situations where vulnerability of code may be available. So we want you to identify that and then diagram it out. And once you've identified it and diagrammed it out where in the pipeline or where in the code this exists, then you can start to figure out how to mitigate and figure out solutions to handle those situations. For example, if you know username and passwords are needed, then use Key Vault. If you know you're working with open source software, then use one of the third-party tools that can scan for security vulnerabilities. Another thing to think about is penetration testing. So as a part of your security best practices, you should be thinking a little bit more about how to add in security penetration testing to your overall process. So again, this is a part of the security threat modeling, right? If you look and identify, oh, it's possible that if people hit this website too often, too many times, they can do a denial of service attack, right? Seeing things like that, you might go, okay, well, let's introduce a penetration testing tool or a penetration testing script that can just test it out for us and actually tell us what our metrics are at the end of the day. And the cool thing about all of that is that there's the Azure Security Center on the Azure portal or Azure DevOps portal as well that allows you to kind of help you through that process. But the questions are not going to be how do you set up penetration testing. The questions are going to be more centered around when should you do this, okay? And last part of this is Azure policies, management groups, secure files, and Key Vault. Just understanding the differences there. So Azure policies are all about infrastructure policies. So sometimes what needs to happen is sometimes you need to put in place a file or a JSON file that explains what network ports are open. It explains how many instances of your server are going to be running, like an auto-scale group type of thing, right? And sometimes you need a management policy that says these groups have access to these systems, okay? So in any case, that has secure information in both of those type of policy files. And so typically what you do is, because it might have sensitive information in it, you don't want to just put those files in your Git repo. Again, you want to put them in a secure location. So if it tends to be files that have sensitive information, you don't put that in Key Vault. You put that in the secure files component, right? So again, designing the strategy, you just need to think about where things go in this scenario, right? If it is username and passwords or secrets or certificates or things of that nature, that's what gets stored in Azure Key Vault. So here's some questions. True or false? Azure Key Vault is the best way to secure SSH key files. Files. There you go. That was the trick. Because it's a file, you want to use secure files. If it's just keys, a collection of keys, not necessarily in a file itself, then individual keys you can store in Key Vault. Is that clear? All right. Which framework scans for vulnerabilities and open source libraries? There's quite a few of them. White source. That's all. White source, SonarQube, right? Quite a few of them do that. All right. Question statement. Which feature allows you to set security constraints on an Azure resource? Azure policies and Azure Management Group. I think they both give you that capability of doing that. All right, which feature allows you to set security constraints per subscription? Yep, management, Azure Management Group policy. All right. Again, designing DevOps strategy is, the last piece of this, I believe, is integration. So what Microsoft wants you to understand that as a DevOps engineer, you're not always working with complete Microsoft products. Sometimes you come into an environment that has all kind of frameworks and all kind of products that you have to integrate with. Now, sometimes the important piece here is those products have to run like in their own environment. Sometimes they don't run in Azure. Sometimes they run on-prem. And understanding that they run on-prem then brings in licensing and agents into the mix. Because if you want, I'll give you a prime example. I was working on a project that was doing some Unity 3D development type of thing, and they wanted us to use Azure DevOps to include their build process into this. Because at the time, Unity didn't have Unity now has a development platform where you can have multiple teams developing, but at the time they did not. So we used Azure DevOps to help this team push their Unity apps all the way out to the mobile store that they were building for. And what was interesting was that we were trying to figure out a way to introduce the Unity build process into Azure. Well, the problem was, at the time, Azure doesn't have an agent that runs in the cloud that can build a Unity 3D type project. So you wind up having to create an agent, or basically it's just a server, be it in the cloud or on-prem, that can connect up to Azure in the cloud in order to compile that Unity custom specific code. So when you do that, now you have to think about licensing. Okay, well, how much is Azure DevOps going to charge me? And is this going to slow down my pipeline if I now have to come down on-premise to run this code, right? So when we're designing the DevOps strategy, you just have to think about these different things, okay? And that's what this is all about, integrating with kind of like third-party tools. So licensing with hosted agents. So just go into the licensing settings inside of Azure, and you can see a quick snapshot of it here, and just understand what this all means. So we have Microsoft hosted agents, self-hosted agents that are available, and based off of the default settings, you get so many jobs available for so many jobs for the Microsoft hosted agent that can run, and so many jobs for the self-hosted agents, okay? So what this effectively translates to is when building out integrations with third-party components and third-party libraries, if you need to have multiple builds running to get the throughput that you're looking for and the velocity that you're looking for, you will have to pay more money if you go past whatever that threshold is. I don't know what that number is because they change it every so often. You don't need to know the exact number for the exam. You just need to know the concept that when you need parallel builds, you need an agent that can run multiple jobs, and that typically means more cost. Clear? All right. Here's some questions. You're a developer that works with Azure DevOps Pipeline. Your environment currently runs a single job at a time in your organization. You have reached the monthly limit on the job. You can no longer run the jobs. You've reached that limit. You need to support 2 jobs at a time that do not reach the monthly limits. What should you do? Actually, what you should do is go purchase more jobs. Really, it's that simple. All right, so that's what I was supposed to say. See, that was easy. Okay, implementing DevOps development process. So we'll spend some more time on this now. So this is another topic, switching context. So this topic is now about getting into the weeds of actually how do you start to implement the various different source code branching strategies. How do you work with version controls, and how do you recommend a code flow strategy? So I'll work our way from the bottom up. When we say a code flow strategy, all we're really talking about is how do you keep track of what developers committing what code and what builds are being kicked off based off of that code they committed, and how to have that audit of what happened. So when you get to the release of your application, you know that a particular bug has been fixed in version 1.02 of the release. Make sense? It's like an audit trail, understanding everything that happened. So that's the code flow. And then it's also about branch policies. It's also about putting in place some standards that say, every time you commit some code, you got to add a comment. Or every time you commit some code, it's got to go to some requirement or work item. Now, I'll tell you from real life, the minute you start putting in a bunch of code flow policies, it does hinder the throughput. Because, developers like to just commit and go. Developers don't like to commit and think about what the commit was for. Developers don't like to commit and actually have to assign it to a requirement, because otherwise you'll have developers hit a space bar and commit and go, yep, requirement's done, right? So sometimes that does slow down velocity and performance by putting in these patterns and best practices. But as we all know, patterns and best practices, there's a reason why we want developers and teams to do this. All right, the next one is recommend version control systems. So what you probably don't know is Azure DevOps supports many different type of repos. It supports Bitbucket, it supports Git, it supports Azure Team Foundation source code repository. So that's what we want to talk about there. And then the recommended branching strategy, well, that's like a big topic. That's like a heated debate on what's the best branching strategy. I try not to get into it, and I just try and point people to the documentation. It's like a 10-page document that says, these are the different type of branching strategies. Now, the exam doesn't really drill you on branching strategies. It more so drills you on when you should think about different branching strategies, all right? But we'll drill into that right now. So version control systems. Just be made aware that Azure DevOps supports different type of source code repositories. They'll ask you questions that assume you know that, yes, you can use Bitbucket. Yes, you can use Subversion. Yes, you can use GitLab if you want to. Okay, yes, you can use some generic Git repos, or you can use Azure's Team Foundation source control. When we talk about branching strategies, what Microsoft wants you to understand, really, is some of the basic ones, such as the main branch that most developers use in the most simplistic case. We just have one branch, everything gets committed to it, and that's that. Microsoft also wants you to understand that there is a development isolation branch that you may choose to use, so developers may have their own branches, basically, or maybe you have branches based off of feature isolation. Or maybe you have release branches. So maybe you purposely create a branch where all your release code goes, right? Those are all different branching strategies that you can use. Just read about, a little bit about what they're for, because that's, pretty much what the exam will cover. And again, source control, this is just a picture outlining, again, what source control, external source controls are supported. Now, one thing I will mention about the branching strategy is this. When I took the exam in beta, which these questions may not necessarily be there today, but it's good to know, and so I put it in here just so that you are aware of it, is making sure you understand some of the Git basics. What's a commit and what's a merge? Just make sure you understand that. And then go into a little bit more advanced pieces of Git, such as fast forward merges, squash merges, and pull requests, okay? So if you understand those, you're more than capable of passing this part of the exam. So that kind of takes us into the code flow part of this. So the code flow part deals with branch policies, okay? So here, this picture is really just talking a little bit more about why we would use branch policies. So maybe what you want to do is require a minimum number of reviewers, right? So that's a good policy to put in place, having people code review. Maybe you want to check for someone added comments when they commit it. Maybe you want to check for someone has always checked their commit against a user story or against one of the work items inside of the Azure boards piece. Okay, maybe you require some type of approval mechanism from an external source or an external system. All of these are reasons why you would have a branch policy. So when they ask you a question, they may ask you something like, they may give you a scenario that says, okay, you have a client that, you are building an application. You have a dev team, you're building an application for a client, and the client wants to review all your code. What do you use to do this? Well, you say a branch policy, okay? That's what you would use to set this up. Now, in the performance-based test example, they may actually ask you to set it up. Now, this is where it gets into the implementation part. So that's fairly straightforward. You don't have to write any PowerShell script to do this. You could, but the exam doesn't really expect you to know the PowerShell script to automate this. All they expect you to know is how to get to the policy branch inside of Azure DevOps. So this is a screenshot here on how to get to it. Another thing that you might want to pay attention to when working with source control is the branch filters and path filters. So this is when you are trying to work with setting up your builds, and we haven't really talked about triggers and all of that, but this is this idea that when people are checking in code, you can tell the build system what to focus on when they commit their code. So that's why we have a branch filter to say, this particular configuration is only for this branch. It doesn't just work with any branch. It has to be the master branch, or it has to be the developer isolated branch, or the feature branch. Right? So you can create different build configurations for different branches. But not only can you do it for different branches, you can also do it for different subfolders within that branch, hence the path filter. So understanding the difference between the branch filter and the path filter is also important, knowing when to use the branch filter versus the path filter. Sample questions. You're a developer that works with the Azure DevOps pipeline. There is a repository that has a large code base with multiple complex features and release branches. Merges take place, which causes one of the release branches to stop building. The merges have no commit history. You need to roll back the changes and make sure that all merges have a commit history. What steps should you take in order to do this? Well, I don't have a slide that tells you all the steps, but I will tell you the steps. Maybe. Sorry about that. All right, so this particular example requires you to know a little bit about fast-forward merges and squash merges, because the difference here is the question is asking you to roll back changes to make sure merges have a commit history. Does anybody here know anything about fast-forward merges? No? Squash merges, maybe a little bit? Yep. Fast-forward merges basically allow you, so when you commit your source control, when someone's coding and they commit something, let's say they're in a branch and they're working on something and they want to merge those branch changes back into, let's say, a main branch, right? There's a history of what happened as they committed their changes to this other branch and that's getting ready to merge back into the main branch, okay? When you do a fast-forward merge, what it basically does is it tries to take that main branch and tries to merge everything in. It takes that other branch and tries to merge everything in to the main branch without keeping the history. So by doing that, then it kind of makes it seem like a seamless branch. What winds up happening is when you have multiple branches and multiple teams and developers are working on their own branch, you start to get into this weird branch mode of, oh man, where does this bug actually hit me? Is the bug over here in this branch, or is the bug down here in some other branch? And it becomes hard to follow when you have 4 to 5 or more branches that are, doing various different things in the code. Okay, so when you don't want to have the history, the problem, and the reason for not having history is because every commit takes up more space, takes up more time in your repository. The repository gets bigger and bigger and bigger. So sometimes you don't want that history. Sometimes you purposely want to go, oh, you fixed it, let's just put it down. But when you lose the history, sometimes it's harder for you to find the bugs. Right? Sometimes it's harder for you to figure out what exactly happened when you do a fast-forward merge. So the idea here is that you don't want to do a fast-forward merge, but instead you want to squash it. You just want to do a typical merge so that all of the history and everything gets brought back into place so you can logically roll back and figure out what happens. All right? And that's the idea of this example. Okay. The build infrastructure piece. So we talked a little bit about hosted agents and Windows hosted agents. In this particular topic, when we are talking about builds, right, the build has a process that has to run. So there's some compute power or some system that's going to actually compile the code. The question becomes, do you know what type of servers that those build agents run on that's supported in Azure DevOps? So the answer should be yes, you do know, because it supports Linux boxes, it supports Mac OS boxes, and naturally it supports Windows systems. So what that technically means is that you can have builds that can build to Apple software, you have builds that can build to Android software, builds that can build to Linux software, and builds that can build to Windows systems. All because we have agents that could be hosted on those particular type of servers that can communicate with Azure DevOps. And so let me swap over to this screen. So the reasons why you may need to have hosted agents, self-hosted agents versus Azure-hosted agents might be because a self-hosted agent may need to run on-premise, or it can run in the cloud, and you can have a VPN that connects to on-premise. That part doesn't really matter. But the reason why you need to do that is because maybe your self-hosted agent needs to access resources that are in your company network. Obviously, Azure that's running in the cloud may not necessarily be able to pipe into your company intranet or your company network. So that would be one reason why you have a self-hosted agent. Another reason is the example I gave earlier with the Unity example. So if you're working with some type of third-party library or framework or tool set that it doesn't exist in Azure, you have to build it yourself. So when you build it yourself, you install the build agent on it, and you have it communicate with Azure DevOps. All right, this screen just shows you how you would install a build agent. So the steps are pretty straightforward. Inside of Azure DevOps, you go into your organizational settings area, and there's a tab called, I think, Agents, Pool Agents. You click on that. First thing you need to do is create, if you don't have any, create a pool agent. You most likely will have at least a default one and an Azure one, okay? You can use the default one, or you can create a new one. And when you create a pool agent, when you create a pool, the next thing you have to do is add an agent to the pool. So when you go into the pool you just created, you add the agent to it, this screen pulls up. And this screen basically allows you to just download a script and run this script appropriately on the said operating system that is supported. So as you can see on the screen here, it supports Windows, it supports Linux, and it supports the Mac OS. So scripts are different for each of the operating systems. Okay, so what the exam would most likely ask you is which one of these OSs are supported for build agents. It might ask you, in the case of Windows, it's not going to drill into details about Mac OS and Linux. It will drill into details about Windows, such as, okay, you've created a self-hosted agent. What do you have to do when you set up a build self-hosted agent? So now you should at least run through this example one time, because it will be always the same. What you have to do is you have to log into Azure DevOps with a personal access token, copy and paste that personal access token into the script, basically in the command window, and then answer a bunch of questions. Like, is this agent always gonna be running? Does it need to run as a network service? What's the network service account you need to run as? And then hit run. Once you do that, your server is now a build agent talking to Azure DevOps. It's really that simple. Another thing that you should be made aware of are service connections. This is a slightly different topic. So service connections are this idea that you want to integrate with third-party systems such as Jira, such as Bitbucket, or such as ServiceNow. Any type of third-party tool that you need to integrate with from the standpoint of tests or the standpoint of builds or releases, you would use a service connection to do that. All this winds up being is kind of like a configuration of a username and password, or an application ID and a secure token, or something that allows you to actually connect up to that third-party system. And it saves in the confines of your Azure DevOps system, right, in your configuration. So what the service connection becomes is an item that you can use inside of your build pipeline. So whenever you have a component, a build task that needs to reference the connection to that third-party system, you point it to this service connection that you have configured. And that's the purpose of service connections. So that's all you need to know, for the most part, about service connections. All right, I will take a little time and talk about the mobile DevOps strategy. So there are quite a few questions on developing applications for mobile devices with Visual Studio Application Center. And this is really all about what's the best way in which you can develop applications for Android or iPhone and allow to make it easy for you to push applications to this Android or this iPhone and get immediate feedback once the application has been built. That's all done with App Center, okay? So this is a picture of App Center. You just need to understand that App Center is a web-based application that you can go to. You have to sign in, create a whole new account. It doesn't it's really somewhat separate from Azure DevOps. It's not like fully integrated into Azure DevOps. It's kind of a little bit disjointed from it. So you literally have to go to another URL, another website, and pull up Azure from App Center. And then once you sign in, you then have the ability of testing individual mobile devices. You have the ability of distributing to registered devices. You have the ability of diagnosing and analyzing those apps that are running on that particular device. Right? So Azure, so the Visual Studio App Center is kind of the tool that you use when working with mobile development. So there were quite a few questions on that, so just keep in mind, whenever they ask you something dealing with mobile device development and testing and distributing, just know you're working in the confines of App Center. Skipping through some of the slides that I drilled down into already. All right. I made mention of this quite a few times, but again, it's worth mentioning again. This is all about application configuration. So whenever you have secrets and you need to store those secrets through your build process and or your release process, it's best to use Azure Key Vault. Azure Key Vault is a mechanism that allows you to store certificates, store username and passwords, store tokens individually, right? And you can access them appropriately. As we talk about Azure Key Vault, you also need to understand that there are some applications that pretty much require Azure Key Vault, and one of those examples would be Azure Kubernetes Service. So Azure Kubernetes Services has certain configurations that you need to apply to it in order for it to run properly, and so it needs a Key Vault entry in order for it to do its thing. So again, this is what Azure Key Vault looks like. It's this idea that we can store authentication keys, storage account keys, PFX files is kind of this is the only file type that you would potentially store in Azure Key Vault. Now it's secure files, Microsoft. So secure files is a fairly new thing that came out, and Azure Key Vaults used to store these PFX files in it, and it's still supported, and the exam would kind of treat it that way. But going forward, you really should be looking at secure files piece for that. All right, so here's some example questions an example question that you would see for mobile DevOps strategy. So in this case, it says your company is developing several iOS and Android apps. You must target devices for deployment based on feature sets. You need to deploy the applications. What should you use? Pipelines, artifacts, repos, or Visual Studio App Center? Exactly, Visual Studio App Center. Yes, some of the questions on the exam are really that easy. Some of them are more difficult. All right, so enough of that. On to continuous integration. So continuous integration deals with this idea of how do we schedule our builds, how do we trigger our builds, and once we have these builds triggered and scheduled, how do we apply these policies, these branch policies to them so that we can do approvals and things of that nature. And then once the builds are triggered, how do we automatically run tests against them? How do we automatically scan the code for vulnerability and different things of that nature? So now we're getting into the implementation of how to do this. So the first thing you should really focus on and be aware of is code coverage. So code coverage is pretty important because Microsoft wants to make sure we understand that when you're using open source packages and frameworks, you're really opening yourself up to potential vulnerabilities. So you need to add in code coverage. You need to add in the scanning of the code to make sure, number one, various pieces of your code, if they're not being used, maybe you need to remove them, right? If you run through multiple use cases of your tests. Various pieces of codes that are using libraries, that are using vulnerabilities, you need to mark them, or you need to be warned that this has a vulnerability and you might need to mitigate that particular action. So the way that's done is through Visual Studio Code Coverage or one of the code coverage tools. They all provide some type of UI that allows you to, number one, run the test or run the process, and it provides a UI that allows you to see pretty much green, yellow, and red. What's good, what's not so good as warnings, and what's absolutely bad. Azure Test Plans is a tool that you can use to launch some of these third-party, well, not really third-party tools. It's a tool that you can use to launch Visual Studio unit tests. So if you use the included Visual Studio unit tests, if you built some of those tests and use like in-unit and things of that nature, you can use Visual Studio tests for that. If you want to run third-party tools, that winds up being a separate task that you have to do inside of your build task. Visual Studio test plans does not really run necessarily like third-party tests like that. All right, come back. The next part of this is working with containers. So context switch again. So one of the main topics inside of Azure DevOps is working with Docker and working with Azure Kubernetes Service, AKS. And so how many people are familiar with Docker? Then you're perfect. They do have a couple of questions that ask you, how do you build a Docker image? So if you know the commands there, you'll quickly pass that. Another example is, how do you push a Docker image into an Azure repo? And it'll ask you to select the command. You don't actually have to type it. You just have to select snippets of the code that allows you to push that container up into an Azure repo. So I remember a couple of questions on that. And again, the purpose of this is, the reason why we have, or we're talking about containers, is because we're starting to get into this area of infrastructure as code slightly, right? We're starting to say, okay, when you're starting to build applications and you need to release these applications, they need to run on some system, right? And so that system should be dynamically created. That system should be used within the process to be provisioned, to be instanced, and all of that. And we can use Docker containers to do this, right? We can create a Docker container that runs a website and load that container up inside of Azure. And the beauty behind it is when you start working with Azure Kubernetes. So Azure, or just Kubernetes in general, K8s. So when working with Kubernetes, it allows you to kind of like create a collection of these containers that can kind of work somewhat like an autoscale group, right? It can kind of work like this idea that I always want 2 instances of this web server running, and but when things get bad, I want you to go up to a maximum of 10 instances, but on average, keep 2 of them running, right? Something along that lines. And we can do that with Kubernetes services with our applications if we build containers. So that's why it's important. Well, I thought I had my, oh, here it is. So what you need to know here with Kubernetes is you just need to know a little bit about the tool set that's used within Azure in order to launch containers, in order to launch Kubernetes, in order to run within the Azure framework. So know what an Azure container registry is, or repository. An Azure container repository is where you store the Docker containers inside of Azure. So you can create these repositories in Azure DevOps, on the Azure portal, and then they're available for you to use inside of your Azure DevOps pipeline. Just point to it. Understand that Helm is the framework or the tool that you can use in order to kick off and configure Kubernetes. It kind of, underneath the hood, calls kubectl and does all kind of interesting things. And understand that Azure Kubernetes Service is the feature that Azure DevOps and Azure Portal utilizes to run and manage a Kubernetes cluster. All right, so understanding those concepts is pretty big in being able to answer a lot of these questions. So another thing to pay attention to is, so for the CI process, where this whole model fits in is, you typically will build your container image in the build pipeline, and you will push the container image up into the Azure repository, right, into the container repository. All right, and then on the release pipeline, you would typically tell the Kubernetes system which image it needs to auto-scale from. Okay, so you would use Helm to do that in the release pipeline or the CD portion of it. All right, so understanding the differences there will again help you out with some of the questions. All right, have to speed up now. So continuous integration. So this is just a diagram on, again, what might happen typically. So we start over here with an engineer that's going to be writing some code in VisualStudio.net. So that's kind of at the bottom left down there. And the engineer then uses VisualStudio.net to commit some code to an Azure repo. So the Azure repo then most likely has some type of trigger or some type of scheduled build that kicks off that says, okay, let's compile the code that they just committed. And so that compiled code, there's a pipeline that compiles that code. So make sure you understand where pipeline fits into this mix. So the pipeline gets triggered. The pipeline has various different tasks that run. And then one of the tasks that runs might be create a Docker container. So that Docker container within the build pipeline would then be pushed to an Azure Container Registry. And then the pipeline will continue executing. In this case, it might be the release pipeline that then pushes a command that says, go ahead and start the Kubernetes cluster and start up your environment and go ahead and deploy the code to that environment. Or really deploy the configuration, because the code most likely is already deployed in the container. All right, so we're almost there. So now it's time to move over to the release pipeline. So this is what we refer to as continuous delivery or continuous deployment. And here we're focused on how do we package, how do we version, how do we work with multiple environments? You might have a QA environment, a stage environment, a test environment, and a prod environment, right? So you may have different environments and you may need to do different things in different environments. Or maybe you have some type of linear flow that says first deploy to the stage environment and wait for people to approve the testing of the stage environment before it deploys to the next environment. Maybe you have some flow that works like that. But again, that's all done inside of the delivery or release pipeline. So one of the things that they'll focus on here for that is recommending strategies for the release pipeline, recommending when you need approval gates, recommending what type of release tools are available for your use, and selecting an appropriate deployment pattern. So let's first delve into deployment patterns. So how many people have heard of blue-green deployment? Okay, good. So for those that have not, we've used the blue-green deployment to make our lives easier for swapping over into real-time, into production real-time systems. So one idea of a blue-green deployment is you have two exact environments, okay? One environment is always active, is always live. It's the real production runtime environment end users are hitting. And then you have another environment that's exactly like that one, but it's the place where it's like a staging area. It's like a place where you can upload changes and features and test them out before they go live. And that's called like the green environment, let's just say. It doesn't matter the name, blue or green, they can swap. And the idea is that when you're ready to swap over, all you do is really flip a configuration switch. You basically say, all right, point everything now to the green environment. And now the green environment becomes live. And the blue environment now becomes the staging area, so that if something goes wrong when you go live, all you have to do is flip the configuration switch back over to the blue environment, and that's how you roll back. Fairly simple, right? So that's kind of this idea. So that's a good pattern to use for systems that, for the most part, can't really have a lot of downtime, right? You need the system always running, and you need the least amount of resistance when you go live with some latest release, okay? All right, what else do we have here? There's also canary deployments. Canary deployments are really this concept where you're doing it a little bit at a time, little piece by piece at a time, and you're turning on features with feature flags. And with these feature flags, you're kind of saying, okay, I have an environment that I'm ready to roll into production by flipping a configuration switch, a feature flag switch that says turn on these features, right? But I give it to a set of beta users first to test it, and then when they test out and everything is good, then I just kind of leave it running. and then I roll over to the other environment and say, let me turn that off now. So if anything ever rolls back, then I turn the feature flag off, and now it kind of rolls back, but it's in this new environment, but it just rolls back to the old behavior, okay? That's kind of the idea of that one. Release management workflow. So setting up release management is all about setting up the release pipeline. So understanding the release pipeline means understanding that the pipeline can support stages and support environments. Also, understanding this means that the release pipeline workflow can support approvals. So we have different types of approvals that exist. So you can have before approvals and after approvals. That's kind of the easy way to look at it. So a before approval is this idea of before we actually deploy to whatever that new environment is, let's make sure everything is set beforehand, the configuration items are valid, the previous environment worked just fine. So before we deploy it to the next environment, I'll either reject it or approve it. So if I approve it, then the actual deployment happens. Okay, and then you have these after approval designs, which allows you to say, okay, we just deployed it to whatever set environment we've deployed it to. Something, it doesn't look good. Let me reject it, so you may need to have some design that says roll it back or generate an issue. Yes? I couldn't hear you. So the blue-green is just a pattern, right? It's just a pattern that you can use with release pipelines to set it up. Is that answering your question? Okay, yeah, take it offline. And for release management, go back. For release management, I mean, that's all you really need to know is that you have multiple phases, you have multiple environments that you could set for, and that's pretty much it. All right, dependency management. So what you need to know here is all about when your applications have a dependency on other libraries and other resources, right? How do your applications reference those other libraries and other resources? Another aspect of it is, what if the application or the library that you're building is a shared resource that other applications use? So the questions are all centered around, how do you set that up? How do you implement a design like that? If you have an application that references a bunch of assemblies, right? How do you access those referenced assemblies? Or if your application itself is an assembly that's going to be referenced by other applications, how do you set it up so other systems can reference that project? So two concepts here. So the way you do it is utilizing Azure Artifacts. Quite a few questions on Azure Artifacts. So Azure Artifacts is exactly like Artifactory, JFrog Artifactory, if you know about that. It's basically like a bin. I call it a bin container. It's a place where you can publish releases, you can publish packages, you can publish DLLs, you can publish executables, and it gives you a versioning strategy. It gives you a versioning history. One thing to make note about it is that it is immutable, meaning once you publish to it, you can't change it, right? All you can do is really just update the version number and go version 1.01. You can delete that version, but you still can't change that version, right? That version in 1.0, it's there, it's immutable, okay? So these are the type of things you could stick up there. It supports Maven, it supports NuGet, it supports all these different package managers that are there. And for the most part, it's how we work with shared resources. It's how we work with dependent modules. Right? There's also a recycle bin, but again, keep in mind, it's immutable. All the recycle bin allows you to do is delete it into this recycle bin, and then it's there for about 30 days, and then eventually it'll go away unless you go into the recycle bin and purposely clear it out. So the questions that they might ask are, you have a system that uses Artifactory, and a developer accidentally deleted one of the versions inside of Artifactory. How do you go get that package again? Well, you go into the recycle bin. Or it may ask you something along the lines of, after it's been after 30 days, and the developer can't find a version of a package that was in Artifactory, what's the cause? And the answer might have something to do with, well, 30 days is the limit for how long files are in the recycle bin, so it's most likely that the system or the package got completely removed. Which is not that big a deal if you've tagged it, because you can always rebuild it again. The problem is that you just can't store it in Artifactory again with that version number. It has to be like a new version number. All right, so understand this, by the older versions of Artifactory, and I believe your exam still is based off the old versions, it doesn't really support Artifactory feeds as a public endpoint. So what that means is that you can't give it a public URL to an external customer. All you could really do is, the new release of it that was announced this week allows you to do it. But Azure Artifactory does support public and internal feeds. All right, so what that means is that you can actually point it to a NuGet public package, and you can configure it that way, and you can point it to internal NuGet feeds, all right? So all of that is supported. Security, Azure Artifactory supports Azure AD. It is something that's secured by way of your Azure DevOps security settings. And another thing you should probably focus on is that you can scan some of the components that are in Azure Artifactory with some of the tools like White Source and Black Duck. Sample question, you're a developer that works with Azure DevOps Pipeline, your environment utilizes Azure DevOps NuGet repository. There's a proprietary shared library that needs to be created and provided to the web development team. You need to create and expose a NuGet package to share the library to all internal teams. What steps should you take? This is all about how to create a NuGet package. So the first thing you need to do is create a new spec file, just a little text file that explains what files are going to be in the package. Then you need to run the NuGet command that actually packages it up. It's kind of like a zip file. It packages it up into this compressed NuGet file. And then you basically deploy the NuGet file into either Artifactory, you upload it into a feed with a version number, or you deploy it to some other bin container. And that's pretty much what's here. All right, last piece, and then I'm going to speed through this. So implementing application infrastructure is all about desired state configuration. If anybody who's ever done anything with PowerShell, desired state configuration, you are golden, okay? Desired state configuration, anybody here ever use Chef? Oh, quite a few of you. I see some of you laughing, I laugh too. Chef is good, right? Chef gives us a way to prevent state drift within our machines. So this idea of I have server 1 and server 2, they're supposed to be alike, but for some reason someone updated server 1 but never updated server 2, right? And our apps are running on it, and now we see differences in how the app is behaving because we have these differences of environments or servers, right? That's this idea of state drift, when the state of the server is drifting over time. Well, Chef allows you to stop that because Chef is a tool or a system that constantly pings the server and checks to see what apps and how that server is configured based off of a Chef cookbook and Chef recipe. Well, PowerShell desired state configuration does the exact same thing, except it's using PowerShell. And if you just read a little bit about PowerShell desired state configuration, that allows you to configure your whole servers in Azure, be it Windows Server, well, it's only a Windows Server thing, last time I checked. But it's something that allows you to create these little PowerShell snippets that say, make sure these features are enabled, make sure this version of this package is installed, and constantly check to keep sure that those servers that are running in either Azure VMs or on-prem or wherever, because it runs anywhere, make sure that they maintain the same state. So the questions that they ask you about are really centered around ARM templates and desired state configuration, all right? All right. And the very last one is implementing continuous feedback. So continuous feedback is the ability to ask end users to test out your application. So we can access continuous feedback by going into the boards option and select, let's say that there's a bug that you're paying attention to inside of boards, right? Because you can also pay attention to defects. People can log defects in Azure boards. And when they're on a particular defect, if a user or a developer has committed a change that is linked to that defect, in that same defect area, there's an area where you can right-click on it, and you can say, ask for feedback. And then it pulls up a window that allows you to, I think I have it up here, that allows you to email somebody and ask them for that feedback. And then it pretty much tracks the user's feedback. It also allows you to template it and type in there like what the instructions are that the user needs to do to test this out, and it tracks that feedback linked to that item. So the tools that you need to know about here to do that are Hockey app, ServiceNow integrates with this, and of course, as they start to run it, you're most likely going to turn on something called Application Insights to monitor it, to keep track of the performance as they're testing out the application. So those three things are usually used in conjunction with each other for the customer feedback. And how to prepare. So the way we prepare for this is you go to microsoft.com/learn, select the apps and infrastructure role, select the AZ-400 exam, and you'll find some hands-on labs. You'll find links. You can also go to Pluralsight. They have videos on the Azure DevOps system. We have instructor-led training, so there are courses on this particular exam as well. So there's many materials out there that allows you access to this and how to prepare. And oh, by the way, there are a lot of slides that I didn't show here, I hid, but you will have access to all these slides. And in these slides, there are notes that have links to every single thing that we talked about today, and you will have that by the end of the week at the end of Ignite. So look out for an email with these slides, and I thank you guys for attending. That's all I have to share for you today. Don't forget your free exam certification. See me afterwards about this. If you have questions on this, you can take this exam today if you want, if you're interested, and use this free exam voucher to do so. Thank you guys.